Alright, so here we go. Question 6. A brand new Rolls Royce rolls off the back of a truck that is being delivered to its owner. The truck is traveling at a constant speed at 60 km an hour. The Rolls Royce slows down at a constant rate, coming to a stop over a distance of 240 meters. There's a full minute before the truck driver realizes that the precious load is missing. The driver brakes immediately, leaving 25 minutes skid mark on the road. The driver's reaction time interval between noticing the problem and depressing the brake is 0.5 seconds. How far will the Rolls Royce be when the truck stops? So for me, the key to this is the distance we need is, let's draw a picture real quick. So the idea is we've got the truck and we've got the Rolls Royce in the truck, and then later on we have this situation. We have the point that the truck, we have the point where the car rolls out of the truck. We have some distance here, which is how far the car rolled, and then we have some distance here, which is how far the truck goes. What we want to know is we want to know what this distance here is. Okay, so the best way that I think to do this is to break it down into two parts. The first part is how far does the car go? The car is easy. It says the car comes to a stop over a distance of 240 meters. So this value here is 240. Perfect. Done. We don't need that at all afterwards. We just needed to know that it was 240 meters. Now I thought, to find the distance of the truck, we need to know how far did the truck go. So we know that the truck spent the last 25 meters when it was coming to a stop. So we know that there is at least 25 meters here where it's coming to a stop. But then between here and here, this big long distance here, before it starts stopping, it's going at 60 kilometers an hour, which is going to equal 16.6. And let me check. 60 divided by 3.6. 16.667. 667 meters per second. Beautiful. So now it's not a matter of. Now we're not looking at how far it is, but we're looking for how long. Well, it just so happens that they tell us this in the question. It says that the driver brakes immediately. Is a full minute, so we've got 60 seconds before the driver brakes, and then but it takes 0.5 seconds for the reaction to kick in. So that means it's ultimately 60.5 seconds that it's traveling at this speed before it starts braking. Plus, don't forget that 25 meters at the end, because that's going to be important. So bringing this all together, we've got displacement equals velocity multiplied by time equals 16.667 multiplied by 60.5 is going to give us, give me a sec, times 60.5 gives us 1008.3 meters. Okay, plus the 25. So then we're going to add 25 because that's this value at the end, means this whole distance here from start to finish is equal to 1033 meters. But that's not what this value of x is, which is what we want. The value of x, well, that can be calculated by saying, well, we know that the truck goes 1033 meters in total, and we know that the Rolls Royce goes 240, so the distance between them, 1033 minus 240, gives us 793 meters. So again, what do? Again, like, this is my advice for anyone that's trying to do a question like this. Draw a picture. This picture helped me when I first did this question to figure out what was going on. I was like, okay, cool. So we know this. We just need to work out this. How do we work out this? Well, we know this part here, and then we just use this information, the fact that it's going this speed, constant, plus the fact that we know how long it is, to get a distance. And then it's just a simple matter of, you know, the total distance, you subtract the smaller distance, you get the total distance between the two cars. Question 7 is a bit more of a challenge. A girl at the bottom of a 100-meter cliff throws the tennis ball vertically upwards. At the same instant, a boy at the very top of the cliff drops the golf ball, so the tennis balls both balls are in the air. Hits the tennis ball there, so that it hits the tennis ball while both balls are still in the air. And this is the key part here. It hits it at the very top of its arc. Now, how did I do a question like this? So what I did was I'm going to draw a picture again. We've got a 100-meter tall cliff. And so we've got someone who's throwing a ball from the bottom, and the ball is going to go up, and then it's going to go down. At the same time, someone throws a ball off the top, and they're going to collide. So how did I do a question like this? Well, I think what's really important for this question is, again, we break it into two parts, but it's important to make sure that we say where 0 is. So I'm going to say this value here at the ground is 0 meters. I'm going to say this, so therefore that would make this point here 100. Why is this important? Well, you'll see. You'll see in a second, actually. Let's start with the easy one. We'll start with the easy one, which is, in my opinion, dark blue, because that is the... we're going to start with the tennis ball. Now, the tennis ball is thrown from the bottom. And what we want to know is, we want to know the speed that this ball is thrown, so it strikes the golf ball. Now, to figure this out, we need to calculate something. We either need to know, we could calculate the speed it is, but that's going to be a bit challenging. I think the best thing to know would be the time. Okay? And the only way to know the time is to know, we need to know the displacement, the point where these two things collide with each other. So we need to work out that. So I can tell you that the displacement at the top of the arc is going to be when the velocity, the final velocity, is equal to 0. That's going to be the velocity when it's at the top. I know that the acceleration is negative 9.8 because it brings it downwards. We don't know what t is. We don't know what u is, and we don't know what the displacement is. So we don't have a lot of information. But what we can do is we could say, well, okay, we'll just leave it there for a second. And so then we'll shift gears over to the golf ball. The golf ball is being dropped. Now, because the golf ball is being dropped, we need to calculate, we know that the initial speed is 0. We know that we don't know what the final velocity is going to be. We know the acceleration is negative 9.8. and we don't know what t is. So what I thought would be really useful, and we don't know how far it has to fall. What I thought would be really useful is using x and t. So what do I mean by that? Well, I thought this would be useful. Let's take the tennis ball. We know the tennis ball is going to go x equals ut plus half at squared. That's it. Sorry, wrong one. We don't know u, so we can't use that formula. So we're going to use this formula. X equals vt minus a half at squared, which is going to be vt, in this case is the final velocity, which is 0. So that's going to cancel that, which gives us x equals negative a half times 9.8 t squared, which is just going to be negative 4.9 t squared. So that's how long, that's where it's going to be after t seconds. After t seconds, it's going to be, after, that's how long it's going to take to get to the top of its arc. If you give it, if it takes 4 seconds to get to the top of the arc, this is how high it'll be. And what we can do is we can do the same thing but with the golf ball. Except instead of using vt, because we don't know what v is, we're going to use ut. X equals ut plus a half at squared. But we can't actually use this. You might say, why not? Because we've got to be careful here. X is the displacement, how far it's fallen. So we've got to be careful because now we've got to change it. Our displacement is going to be x equals 100 minus ut plus a half at squared, because this value here is the distance fallen. And so when you subtract that, that's going to give you how high above the ground it is. And we do this because we can then go, oh, by the way, this cancels, and that's going to be minus 4.9 t squared. We do this because we know that at the top of the arc, these two things will have the same position. So that means that negative 4.9 t squared equals, in this case, 100 minus 4.9 t squared. Sorry, I'm wrong. And negative times, no, I was right. No, that's going to be negative. So that's going to be a positive there. That's why that works. So then when you see this, you might say, okay, cool. Also, that's a negative as well because it's negative 9.8. So it's also a positive. Whoopsies. Sorry, guys. Look, I've even got here negative a half times negative 9.8. So now, when you wait, hold on. Sorry, I've made a mistake. Let me see, where's the mistake? I've got a mistake with these negatives here somewhere. That's going to be plus half at squared. So that's going to be a negative. So it's going to be a negative. Negative times negative makes it positive. No. Pardon me. I did this before and it worked. Subtract this question. This is BT. I made a mistake here and I apologize. I can't straight away see where that mistake is. Unfortunately. Negative times a negative makes a positive. And then this one is a negative times negative also makes a positive. The reason that this is not going to work, as you can see, is that when you subtract 4.9 t squared from both sides, you're going to get 0 equals 100, which doesn't work. Unless this displacement is going to be negative already. I think this displacement is going to be negative already, actually, because it's going down. Yeah, this displacement is going to be negative already. I'm confused, so I don't need to subtract it. I need to add it, which makes this come out to be a negative. Sorry about that. It doesn't really matter ultimately, because once you move this over to the other side, you end up with 9.8 t squared equals 100. That's going to mean that t squared is equal to 100 over 9.8, which means ultimately that t is going to equal, give me a sec, 100 divided by 9.8, and then you're going to square root that. 3.194. 3.194, and you can use that to answer these next two questions. Ultimately, the first one was the initial speed of the ball, of the tennis ball. Well, we've now got VAT, so we can calculate U. V equals U plus AT. 0 equals U plus subtracting 9.8 times 3.194, which means that U is going to equal times 9.8 gives us 31.3. Now I understand that that's not the same answer as what's in the 31.3 meters per second. Now I know that's not the same answer that's in the back of the book, but that's what I get, and it's really close. So either I've made a mistake in rounding off somewhere, but I'm pretty confident with that answer. If you think I've made a mistake though, and you'll find out where it is, then let me know. As for the other question, what is the position of the tennis ball? Well, that's just, you've just got to calculate x. So you just got to substitute it into one of these things. So let's just substitute it into here. X equals 4.9 times t squared, which is in this case 3.194 squared, is going to give us 3.194 times 3.194 times hold on, give me a sec, times, what was it, 4.9 gives us 50. Not only that, but around 50. So 50 meters. So that's actually this point here. So that's the point where the two things collide. That is how I got those two problems there. I hope that helps you out. That's all I'm going to do. Thanks. Bye.